This other picture that, you know, lots of people like, which I don't have a high opinion of. Chemists love this and they simulate it. So it's given to computer simulations and, you know, pretty pictures. It's called Langevin picture or drunken sailor picture. Chemists and other practical people say, well, you know, if I have a particle and I want to understand how it moves, it might be drifting because there might be, you know, electrostatic potential that says I'm supposed to go this way at some velocity. So they call this thing drift. Now this is a first order equation in time. And then they say, well, you know, but it keeps getting hit by something. So that's called noise. And for the noise, you know, you make simplest assumption possible, which is that on average you get hit left or right in the same amount. So the mean of this variable, random variable, is 0, expectation value. So the first thing that's non-zero is the second order thing. And that has a property in general, you know, in isotropic case, we have a property that if they're different direction, they should be uncorrelated, so this average is 0, but if it's same direction, this is a square, a positive number, possibly cannot be 0. So it's called diffusion constant, but in general, it's called diffusion tensor. It might be different directions. Now, if you do computer simulation, you'll get a pretty picture that the particle will be moving, and, you know, you always take resolution of, you're doing it finite time steps, but you'll take a resolution that on a piece of paper you cannot see the same stuff. So it'll execute this beautiful Brownian motion that you have seen. And I have a property that every time I do this, I'll get a different trajectory. And what Fokker-Planck or density description says is the cloud of them will average itself nicely out, but every individual trajectory, if I insist that it's experiencing noise, there will be some horrible fractal thing which on any scale will look fractal, meaning it's continuous, but its velocity is changing all the time.